All right, so we're going to begin 4.5 for our differential equation class, which is on the superposition principle. And I want to first, I left off last class giving you a couple problems to try. The original question looked like this, where you were given the following second order differential equation, and here were some various f of t's. And what I'm doing now is I'm just producing the answers for you. If you are not following me with how I got these answers, then why don't you check in with me during office hours. Let me see if I can help explain it. But the idea is the first thing you want to do is find the roots of that second order differential equation by getting it to its auxiliary form. And then you find your roots, and then based on the roots, whether you have no root, single root, double roots, you adjust your equations, right? So again, this was the point, the topic of last class. So hopefully you can, at any point in time, you can pause the video so that you can see what all I've written here. And then I will just leave it to you to chime in during office hours if I can help you understand something. Now, the next topic, the idea is I can kind of take this superposition principle, and I can make it fairly easy to understand if we just take an example we've already done. So recall for a second that in the previous video we found the solution for the following differential equation, right? And that was y equals 3/2 t minus 9/4. We also found the solution to the following differential equation, which was y equals 1/2 e to the 3t. Now, what this superposition principle tells us is, let's imagine differential equation of the form y double prime plus 3y prime plus 2y is equal to 3t plus 10e to the 3t. Now, we know that the solution to this differential equation, or let me restate what this principle tells us, is that the solutions to the differential to these this form of differential equation can be found simply by establishing or attaching constants to the two previous known solutions, right? So we're just going to do a linear combination of the two previous solutions. It looks something like this. So let's just say c sub 1 multiplied by 3/2 t minus 9/4 plus c sub 2 multiplied by 1/2 e to the 3t. And what I'm attempting to tell you is that if you have any form of a second order differential equation, if it takes on this form, it is separated by a choice of two different scalars, right? Two different weights, basically. And the way I'm going to make this explicit for you is I'm going to give you, on the next page, I'm going to give you an equation that's very similar to this. And I'm going to show you, since you've already done the work to find the solutions here, I can show you how you can use the previous work to find the solution to a differential equation that's very similar in form. So take a look at the following. So notice that we still have y double prime plus 3y prime plus 2y, just like we had before. Only now, instead of having 3t, we have negative 9t. And instead of having 10e to the 3t, we have 20e to the 3t. So what I mentioned is that this principle, which I'm going to just simply offer to you this first quick video as just a quick tour, and then we'll kind of dive a little bit deeper into it. But what this principle allows us to do, it tells us that I can get to solutions to negative 9t from some combination of this 3/2 t minus 9/4. So, or some scalar that's going to contribute here. And now, let me, again, since this is just a quick video, let's see if we can get to where I want to be. So, what we're going to do is we're going to take a look at the right-hand side of the equations here, right? So we have 3t plus 10e to the 3t. Those we've already gone through and have found the solutions for. And negative 9t plus 20e to the 3t is the one that we are attempting to find the solution for right now. So if you would like, you can go through all the work that we've done in 4.4, where you're trying to break it up into the right form and so forth. But let me see if I can show you how to use this superposition principle. So if we take just the 3t and the negative 9t, focus on that first. There has to be some scalar where that I can scale 3t to equal negative 9t. And so in the same wise, there has to be some scalar where that I can scale 10e to the 3t such that I get 20e to the 3t. All right, now those scalars are pretty easy to spot, right? Those, in this case, c sub 1 would be negative 3, and c sub 2 would be positive 2. Now, the question then becomes, well, how does that help me find the solution to that differential equation? Well, recall on the previous page, I had written c sub 1 multiplied by 3/2 t minus 9/4 plus c sub 2 multiplied by 1/2 e to the 3t. And just realize why, just because I've gone through this fairly quickly, you were asked to find the solution to a differential equation that resembled a solution you had already found. So let me write what it is that you're actually trying to find the solution for. So it's as simple as, once you have your scalars, it's as simple as just plugging in. So we got negative 3, which we're going to distribute to 3/2 t minus 9/4. And then we're going to have 2, which we're going to distribute to 1/2 e to the 3t. All right, so I'm going to go ahead and distribute, and then I'm going to combine. And what is this solution? What is this y that we get? We get negative 9/2 t plus 27 fourths plus, well, half of 2 is 1 e to the 3t. This is the solution to this differential equation. Now, so in other words, you can think about this superposition principle as a time saver, as very much a time saver, when you've already done a lot of the work of the of the forms of your solutions, right? So what we'll do is we'll go ahead and we'll stop early, and then for this part A, and for part B, we'll dive in a little bit deeper and practice this this principle a little bit more. See you soon.